Alright, so here we have question 10 of the November 2018 Grade 12 South African Syllabus CAPS Math Exam Paper 1. Question 10, let's get into it. Okay, in triangle ABC, let's say D is a point on AB, we can see that E is a point on AC, and F is a point on BC. And then DECF is a parallelogram. So DECF, so this is a parallelogram. Right, now they give us some information about ratios. BF to FC is 2 to 3. I'm just going to draw that in here. Okay, so BF to FC. Should I draw this here? Yeah, let's do this. So BF to FC, so that's 2 to 3 for BFC. Ooh, that's an F. C. And the perpendicular height AG intersects at DE at H. Okay, so this length is intersects at H. So we've got another line here that forms a parallelogram. And they say AG is T units. So this length is T. Alright. Now BC is also 5 minus T. So this whole thing is 5 minus T. Alright. Write down the ratio of AH to HG. This is point H. So AH to HG. Okay, first thing we notice, this is 2 to 3, and this is a parallelogram, then we know this line and this line are equal, right? So we can also put a 3 here. And let's write DE. Okay, so I'm going to redraw something. So, yeah, let's just do this. Okay, so if this length is 3, and this whole length is 2 plus 3 is 5, right? So if we've got a similar triangle here, and this length is 3 and this is 5, then we know the smaller one is 3 to 5, right? 3 and the big one, 5. So that leaves a 2 here. Same this side, 3 and a 2 here to give us a total of 5. And now the same if we draw any line in here, right? This will be the same thing. This will be 3 for the whole length 5, so this will be a 2. So 3 to 2. So it'll be 3 to 2. This is just because of similar triangles, right? Because ABC and ADE are similar. The ratio of this length, and let me actually draw that in. So the ratio of this length to this length, right? The small to the large, it's the same as the small one to the large one, right? And the same as this small one here to this large one here. All of those are 3 to 5. So that means all of those are 3 to 2. 3 to the same as the, or to the large one, 5. So it means 3 to 2. 3 to 5 for the whole one, so 3 to 2 for this small one. Okay, I hope that makes sense. I know some of these things sometimes feel quite a bit tricky, but it really isn't that bad, especially if you just look for similar triangles. That's going to be a big help. So for 10.1, let's just write down our answer. Let me just switch from the straight lines. We get 10.1. We found our answer to be 3 to 2, right? 3 to 2. 3 to 2, just because of similar triangles. Alright, now we get to 10.2. 10.2. This says, calculate T, okay? And what else, what do we know about T? We know this whole thing is T, right? And we know this whole thing is 5 minus T. Okay, calculate T if the area of the parallelogram is a maximum. So we're going to find the maximum area that this parallelogram can be in terms of T. Right. Okay, so how will we go about that? Well, they give us some nice information here. They tell us the area of a parallelogram, so we can start with that. The area of the parallelogram is the base of the parallelogram multiplied by the perpendicular, let me rewrite that, by the perpendicular height, right? Okay, so what is the base of our parallelogram? The base is this BC, not BC, FC, right? From here to here. That's the base of our parallelogram, FC. Now, what is the value of FC? Well, we know this ratio is 2 to 3. So FC is 3 over 5 out of BC. 3/5 of BC. and we know what BC is. BC is 5 minus t. So FC is 3/5 of BC, and BC is 5 minus t. So that is our base. Okay, let's write the formula here with what we know. So that's 3/5, 5 minus t. Okay, now we're going to multiply that by h. So h is the perpendicular height, that's this one. So we know this is 2/5, right? 2 to 3 or 2 to 5 for the whole line of AG. So it's 2/5 of t. So h is 2/5 of AG. And we know what AG is. AG is t. So 2/5 of t. 2/5 t. Right, so that's the area of our parallelogram. Now let's simplify a little bit. Let's multiply this in first. So 3/5 times 5 is just 3. And then 3/5 times negative t is negative 3t/5. And multiply that by 2/5 of t. Okay, 3 times 2/5t is 6/5t. And then negative 3 times this, so negative 6/25t squared. Alright, so that's our area of the parallelogram. Now I want to find out what the maximum area. So how do we find a maximum or minimum? That's right, we differentiate and put equal to 0. Because this represents some graph, and we don't need to know what the graph looks like, but the maximum will be where the gradient is 0. So we need to differentiate, put equal to 0 to find the point. So we're going to differentiate our area formula. And that'll give us, what is this? 1 times 6/5 is 6/5. And then t to the power 0 is just 1, so we can ignore that. 2 times negative 6 is negative 12. T to the power, 2 minus 1 is 1. And we can keep the 25, that's fine. Right, now I want to set this equal to 0. So 0 equals 6/5 minus 12t/25. And now we just want to solve for t. Okay, so I'm just going to take this over. 12t/25 equals 6/5. Multiply this side by 5, so we get 60t. And multiply this side by 25, so we get 150. And then we divide both sides by 60. So 150/60 is 15/6. And we can divide both by 3, so we get 5/2. 5/2. So the basic idea here was just to say, okay, find the area of a parallelogram. We know the formula, and then we use the ratios and the values they give us here to just get an area. Once we have the area formula to find a maximum or a minimum for anything we want to find, we just differentiate and put equal to 0, solve for the variable. So that's exactly what we did. Found an area for the parallelogram by using the equation they gave us and the formula they gave us, substituting our values that we found from the ratios, and then we just differentiated it, put it equal to 0 to find for which t value we'll have a maximum. Great, and then I'll see you again for the next video.